In this video, we're going to learn about percent yield. So what is percent yield? Well, it's the amount of product that is actually formed in the lab compared to the theoretical amount. In a real lab, you never ever get 100% of what you expect to get. There's always some degree of error in there. So percent yield allows us to kind of calculate what that error might be. So what is the theoretical yield, and where do I find it? The amount that should be produced if there were no error involved. This comes from stoichiometry. So theoretical yield is the amount you would get in a perfect world. It's the amount you would get, the amount that you calculated you would get from your stoichiometry problem. So the actual yield will have to be given to you in the problem, because you can't just stop taking a quiz or a test, hop over to the lab, do the lab, and get some data. So it'll be given to you. And the formula that you need to know is right here. Percent yield is equal to the actual divided by the theoretical times 100. So let's look at a problem. So we're going to follow our steps. If the theoretical yield for a reaction is 14.8, so theoretical yield is 14.8, 9.25 grams were obtained. So look for words like were obtained, were made, were produced. That's going to help you find your actual yield. So actual yield is 9.25 grams. Theoretical yield is 14.8. So we plug those into the formula. So 9.25 divided by 14.8 times 100. And we plug that into our calculators and we solve it, and we get, there we go, 62.5% is our answer. So the formula itself is not bad, but here's what happens. Let's look at this example. Silver bromide was produced by reacting 200 grams of magnesium bromide and silver nitrate. Calculate the percent yield, so we're looking for percent yield if 375 grams of silver bromide were produced. So I see these words were produced. That tells me that I have an actual yield of 375 grams of silver bromide. But look, they told me that 200 grams of magnesium bromide reacted with silver nitrate. So I don't have a theoretical amount here, so I have to calculate it using my stoichiometry. So of course what we have to do is do a balanced chemical equation. So that's going to look like this, and we do have to balance it, so there should be a 2 there and a 2 there. Alright, so we start with 200 grams of our magnesium bromide. We are trying to find the theoretical amount of silver bromide, because they told us that our actual yield is 375 grams. Okay, so we got to find a theoretical amount here. So let's start our stoichiometry. So we have 200 grams of magnesium bromide. We're going to convert that to moles. The molar mass is 184.11. Okay, so we get 1.086 moles of MgBr2. Alright, now we've converted to moles. We need our mole bridge. Alright, so let me see if I can find a different color. This will work. Alright, so I need my mole bridge. So I need moles of MgBr2 on the bottom. I'm going 2 moles of silver bromide. So I look at my coefficients. There's a 1 and a 2. Alright, so I'm going to solve that for moles. Now, I'm out of room. Of course, you can carry that through. But that produces 2.173 moles of silver bromide. I don't want moles, right, because I've got grams here. So let me convert that then to grams. So the molar mass is 188 grams of silver bromide. So I get 408 grams of silver bromide. Alright, so this is my theoretical yield. Oh, sorry, thought it would delete. Nope, not one to delete. There we go. Alright, so my percent yield here, hang on. Okay, sorry. So my percent yield here, I'm going to take my theoretical and I'm going to divide that by my actual. Let me get another pen going here. All right, here we go. So my theoretical yield is this. So 375 divided by 408 times 100. That's going to give me my percent yield, which is going to be, whoops, sorry about that. So the percent yield is 92% basically. And so that's how you do percent yield. You've got your formula, percent yield divided by theoretical yield. From time to time you will have to calculate a theoretical yield based on stoichiometry.